Welcome to Lesson 8, Naming and Formula Writing for Multiple Charges. Our objective for this lesson, identify binary compounds containing multiple charges by name using Roman numerals and construct chemical formulas for those binary compounds containing these multiple charges. When we look at FeCl2 and FeCl3, these are very different compounds, but if we name them the way we've learned already, they seem to have the same name, which is iron chloride. But they are very different compounds with different properties. So how do we differentiate between them? Well, FeCl2 is actually called iron 2 chloride. This is the Roman numeral 2 here. And FeCl3 is iron 3 chloride. So what do these Roman numerals represent? They actually represent the charge of the ion that's being used. So in iron 2 chloride, the 2 represents the +2 charge of the iron in this compound. And in iron 3 chloride, the 3 represents the +3 of the ion of iron that's being used in this compound. So transition metals, these are the metals in the middle group of the periodic table, which are in this area here, and nonmetals, which are on the right of this black staircase here, are going to have more than one charge, typically. So since they have multiple charges, or we say oxidation numbers, we must show which charge is being used with Roman numerals when we decide to name these compounds. So again, if you look at Fe, you see it has 2 charges here. And so if we're trying to write the chemical formula, let's say for iron 2 oxide, it would be Fe. So these transition metals and nonmetals, they could have multiple charges or oxidation numbers. And so it's important that we designate which one is being used using Roman numerals. So for example, if we're using the +2 ion with an iron-containing compound, we would actually designate that with the Roman numeral 2 here. So how do we determine the charge? Alright, so first thing we're going to do is we're going to check to see if the first element has more than one charge listed. So when you're given a compound, like the example here, we're going to look up the first element and see if it has more than one charge. So I look up Fe, and I see that it has 2 charges listed. So automatically I know I need to use Roman numerals to designate which charge is being used. Next thing you do is we're going to find the charge of the anion. This is the element that is listed last, the negative ion. And it will always be a negative charge. So I look up Cl, and it's going to be the top one, which is -1. And I'm going to assign that to the chlorine. So each chlorine is a -1 charge. I'm going to set the whole thing equal to 0 as we've done before. So -1 times 3 is -3 because there are 3 chlorines. Each one has a -1 charge. So the total is a -3. So now I know that the Fe, the total charge of iron, must be +3. And so I can solve for then the charge of Fe, which is now +3. And the last thing, we're going to name it exactly the same way we named it in our previous lesson. The only difference is we're going to indicate the charge of this cation using Roman numerals. So we would say that this is iron +3. So we say iron Roman numeral 3, Cl is chlorine, becomes chloride. So it's iron 3 chloride. So again, the Roman numeral is representing the charge of the iron, not the subscript. Let's see another example. So first thing we do, we look up the first element. You see that iron has more than one charge, so we know we need Roman numerals. Next thing I do, I look up the charge of the anion. Chlorine is -1. I assign that. Set it equal to 0. -1 times 2 is -2. Therefore, Fe must be a +2. I assign that oxidation state or charge to iron. And then I write the name iron 2, indicating the +2 charge, chloride. So again, that 2 is representing that it's using this ion in this compound. Let's do the next one. First thing we do, we look and see nickel has more than one charge listed, so I know I need the Roman numerals. I assign the charge to my anion, the one that's listed last, so oxygen is a -2. Set it equal to 0, so -2 times 3 gives me -6, so the total charge of 3 oxygens is -6. and therefore the total charge of my 2 nickels must be plus 6. But since there's 2 of them, each nickel is going to be plus 3, because plus 3 times 2 gives us 6. And so we're using this plus 3 charge for the nickel in this compound. And we would say it's nickel 3 oxide. Let's see another example. Same thing, I look up the first element. In this case, it's a nonmetal, nitrogen, and has many charges listed. So next thing I do, I'm going to look up the second element. Oxygen's a -2. I assign that, set it equal to 0. -2 times 3 is -6. Therefore, my 2 nitrogens, the total charge must be plus 6. If I have 2 of them, each one's going to be plus 3. And so I'd say it's nitrogen 3 oxide. Last one, I look up P. Also a nonmetal, has more than one charge, so we need Roman numerals. Now I look up the Cl. That's a -1. I assign that, set it equal to 0. This is -3. That means P must be plus 3. And then my name is going to be phosphorus 3 chloride. Let's check your understanding. Can you identify binary compounds containing multiple charges by name using Roman numerals? All right, let's look now at writing chemical formulas. So if you're given the name, how do we write the chemical formula? So first thing we're going to do is going to write the symbol for both of these. So cobalt is CO and chloride is Cl. I'm going to write the charges. So for chlorine, it's a -1. For cobalt, they're telling you now with the Roman numeral what the charge is. So there are 2 choices, plus 2 or plus 3. They're saying it is Roman numeral 2, so plus 2. So I write my charge, set it equal to 0. So this is plus 2. This is -1. How do I get it equal to 0? I need 2 chlorines, because 2 times -1 is -2. When I write my chemical formula, it's going to be 1 CO and then 2 of my chlorines. So COCl2. And make sure that O is lowercase. And for the last one, so chromium, say I have 3 choices listed here. They're telling you they're using the plus 3. It's not the third one down the line. It's saying it's using plus 3 charge. So I write chromium plus 3. Oxygen is a -2. So plus 3 and -2. Set it equal to 0. And the only way we can get a 3 and a 2 to equal 0 is going to have 2 of the positive and 3 of the negative. Because 2 times plus 3 is plus 6. And 3 times -2 is -6, and that will equal 0 and make this compound neutral. So that means I have 2 CRs and 3 Os. So my formula is going to be Cr2O3. Let's check your understanding. Can you construct chemical formulas for binary compounds containing multiple charges? At this point, you should be able to identify binary compounds containing multiple charges by name and construct chemical formulas for these binary compounds containing multiple charges.